Welcome to the first video in the LeetCode series. In this video, we're going to be solving the first LeetCode problem, toSum. Let's get started. So toSum, we are given an array of numbers and we are given a target. And our goal is to find the indexes of the numbers that add up to the target. So in an example here, we have this array right here, and our target is 9. So the two numbers that add up to 9 are going to be 2 and 7. So the indexes of those numbers are 0 and 1, which is why we return 0 and 1 here. So a good, or not a good approach, this is the brute force approach to the problem. A brute force approach to the problem is we iterate through all of the numbers and add them, or we find all possible pairs or all possible sums, and then we just return it when we find that the sum or one pair is equal to the target, and then we return the indexes. So this would work by, we start at the first index and then we go through all of them. In this case, we would just find at the first one, but just pretend that it's not there. If this is not there, then we would have to go through all of them. Then if we don't find the pair in this first iteration, we would go to the second number, where we just check all the numbers after that number and see if any of those add up to the target. And if they do add up to the target, then we'll return the index of the number that, or the first number, and then the number that we have in the second loop. And the time complexity of this, in the worst case, this would take O to the n squared amount of time, because we're iterating through the size of the array every time that we go through the iteration. So on this first iteration, we would go through the array n times, and then the second one n times, and then that would just equal O to the n squared. And our space complexity is constant because we're not constructing any new variables in memory. So that is the brute force solution. Now let's go into the more optimized solution. So this more optimized solution would require a trade-off in memory for time, which is usually the best way to solve it. And in this case, we would be using a data structure called a hash map. So the way we would construct our hash map is we would have a key and a value. So in this case, we're going to store the key as the number in the array. So we just store the number. Alright, this is a bad way to explain it. Let me just write down the array again. So we have 2, 7, 11, 15. And let's see. So we start off at this number. So the approach for this is we're going to find the complement of this number between the target. So the complement between the target and this one is just going to be the difference. So 9 minus 2 is 7. And on this first number, 7 is not going to be in our hash map yet. So we're just going to store 2 inside the hash map. So our hash map, let's create key value. So we have 2 as our key now because we couldn't find 7 in the hash map because it's over here. It's not in the hash map yet. And our value is just going to be the index that we have. So it's going to be 0. Now on our second iteration, we'll have 7. So the difference between the target and 7 is 2. And we found 2 in our hash map already. So now we can just return the index of this number that we found and the value of the key in the hash map. And so the time complexity for this would be O to the n, because in the worst case, we only have to iterate through the entire array of n size. And the space complexity, however, would be O to the n in the worst case, because in the worst case, we have to construct a hash map of size n, where n is the size given in the array. And yeah, that's the hash map solution. So now let's switch over to the actual coding part. Have it open right here. So let's go ahead and code our solutions up. So the first solution that we had was a brute force solution where we iterated through all the pairs. So how we're going to do that is just create 2 for loops. The outer loop is going to iterate over the numbers once, and then the inner loop is going to iterate through every number after the ith number. So we iterate through every number after the ith number, and then we just do a simple check if the number of the ith index plus the number of all the possible pairs is equal to the target. And if it's equal to the target, then we're just going to return the I and j value. And yeah, this should work. Let's go ahead and run this. Yep, now let's go ahead and submit this, see if we missed any edge cases. So yeah, that one works. And let's go ahead and code up the more optimized solution. So in this solution, we had a hash map, and I'm just going to create a map that defaults to an integer as a key, so we don't run into any key errors. Or this results as an integer as the values, so we don't even if we add something to the hash map, it'll give an automatic value of 0, so we don't run into any extra like errors that we don't need to, and it makes our code cleaner. So I'll just use the default bit. And now we're just going to iterate over the numbers in the array, and then for each number we have to find the complement, so the difference between the target and the number that we're at. And if this number, or if the difference is inside the map, then we return the index of the difference, as well as the number that we're at, or the index that we're at right now. So it's just gonna be I. And then otherwise we'll just store we'll store the key value pair with the number as the key. So we'll store the number as a key and the index as a value. And yeah, this should work. Let's try this. Yep, there we go. And submit it, see if we missed anything. And yeah, there we go. Those are 2 solutions to 2SUM.